In the next few minutes, we're going to take a look at the electromechanical demonstration using solid edge with synchronous technologies. We're going to use for this particular demonstration a design from Custom Signal, which is basically an overhead console that has a video system installed in it. Now I'm going to identify the top level assembly in the working folder and change to the initial display configuration and simply open up this top level assembly. Now for this demonstration we're going to look at a lot of different things that Solid Edge offers our customers, and the first of this is the Sheetmetal environment and the process specific, a lot of the process specific commands that the Sheetmetal environment offers our users. As I roll over this model, you'll notice that it's made up of several different components, but in order to be able to kind of focus in on our design task, I'm going to change our display configuration to that of the build Sheetmetal, which is the number 2. And you can see that that turns off a lot of information so we can kind of focus in on our design task. I'm then going to in-place activate into the subassembly in which I want to create this Sheetmetal part. We can also use in the parts library the create in place command, and you'll notice I'm using a custom.psm that's provided with this demonstration. I'm going to give it a name. We'll just call it bracket for a simple name, and we're going to use the offset from assembly origin. Now once I do that, all I have to do is identify, in this case, the top corner of the model, which is going to set up the reference planes where right at the top of the model. And then I'm going to turn on the background component so we can kind of see what we're making here. And plus we're going to use some of that information to assist us in modeling this Sheetmetal part. Now once we in-place activate or do the create in place, it takes us into the Sheetmetal environment where you'll see Sheetmetal commands only. The first command we're going to use is the tab command, and I'm going to identify the reference plane. And then what we want to do is just simply include information. So here we're going to use the design that's already there to help us identify the outer perimeters of this tab. Solid Edge also offers some great trimming tools that allows us to trim these corners and create our closed profile that we're looking for. When we're done with that, we can simply close out of the sketch, and then we're going to use the default thickness, material thickness, but we'll go ahead and select in the upward position. Now once that's done, I'm going to go back to Pathfinder and just simply turn off the reference planes. And then what I want to do is we'll turn off the background components and go under the corners option to grab the break corner. Here we're simply going to use the chamfer option with the select from face, identify the face, which will automatically identify all 4 corners for us automatically, and set that chamfer at 1/4 inch. And when that's complete, we can turn on our design back on. The next command that I'm going to use is the Flange command. Now, the nice thing about Solid Edge Sheetmetal is it's very simple to use. With the Flange command, all you have to do is identify any one of the edges. It doesn't really matter, and then simply drag your cursor, and you'll notice that it'll actually pull that flange down. Now, in this case, I'm going to go over and use under the edge step. I'm going to use the centered option. You'll notice it centers that particular flange, and we'll come down about 1 inch. So I'm going to key in a 1 inch and then lock it in by clicking to place it. Now once that's placed, what I want to do is I want that particular flange to be in the middle of this particular groove here. So what I'm going to do is I'm going to come over to the offset step and change my key point to circle, and then I'm simply going to pick up that circle so that it puts it right in the right location that I'm looking for, and you can see how it fits in there very nice. When that's completed, the next thing that I want to do with this particular flange is to go ahead and break the corners on it as well. And this time I'm going to use radius and simply going to select those 2 edges. And for this, we're going to use a 1/2 inch. Now remember, it's 1 inch wide, so it should consume the entire flat end of that particular flange. The next thing that we need to do is we need to be able to mount this particular bracket on this shaft, so we're actually going to have to create a hole. So I'm going to go to the cut command, identify that front face, and I can actually include some geometry, but what I'm going to do is rotate the view. You're not locked into working in the view straight on if you don't want to. And again, we'll use the include command, but this time we want to set the include with an offset. And then we just simply identify the diameter, and once we accept it, it allows us to key in an offset value. In this case, I'm going to use a 0.03, and then simply accept it, and then close and return back out, and you can see that it gives us the option to create that cutout, and I'll go ahead and accept that. So we've very quickly created a flange that's centered about this particular tab that we created. The next thing that we want to do is create a flange on the end. For this particular flange, we're going to look at a little bit different option. We're going to use from the at end option, and you'll notice here I just need to identify the end I want to work from, and I'm going to select the left side. And then I'm going to pull it up and key in a value of 0.5. And then we'll go ahead and click to place it. Now, one of the neat things here also is that I can not only change the width of this to 1 inch, but I can change the angle of the edges if I need to do that. So it does allow you to very quickly make changes to any of the dimensions when it creates these particular flanges. Another thing that we want to take a look at is you'll notice that it automatically gave us a broken edge or corner here, and if I go into the options, bend relief, and if I go into the options, we can change that from square to round. And you'll notice there that it automatically changes that bend relief to round, which is really good. Now the next thing I'm going to do is turn off the background components, because what I want to do is I want to replicate that particular flange to the opposite side of the part. In order to do that, I can come over to the mirror copy feature. I'm going to use the smart option, and then I'm going to simply identify that particular flange that we just created, accept it, and then we're going to use parallel reference plane off the back side and just simply pick up center point, and it will mirror that to the opposite side. That makes it real easy to replicate some of the information, and we're going to do a little bit more of that in just a minute. We're going to create one more flange to show you some more neat things that comes automatically with the flange command. And for this particular flange, I'm going to come up 1 inch, and then I'm simply going to place it. Before I get out of the command, you'll notice that when we place flanges, we have 3 options. Material inside, where the bend is inside of the edge of the material. We have material outside, and you'll see that the flange automatically pushes the material to the outside of that original edge. And then we have bend outside, where it pushes the bend where it starts at the outside edge of the part. So again, a lot of flexibility when creating flanges. Another process-specific command we refer to as a hem. And what we're going to do, if you want to get rid of sharp edges on your part, this works really well. It also works well when you want to lock pieces of sheet metal together. You'll see what I mean. When I select the edge, it automatically creates a hem. Now, this might not be the exact hem that you're looking for, so all you have to do is come over to the options dialog. You'll see that you can key in and use different sizes. In this case, we just have default sizes, but maybe you want to do something like an S flange. If you click on the OK button, it's going to show you what that looks like. There are several other types. You can do open loop, closed loop, but in this case, we're just using the closed. We are going to turn on the mitered hem, though, 45 degrees on the corners, and very quickly achieve a nice looking hem on that part. The next thing that we want to do is create a cutout. And in this case, I'm going to use what we refer to as a normal cutout. And then I'm going to identify the face that I want to draw that on. And I'm simply going to draw a rectangle, and then quickly add some dimensions to it. In this case, I want this to be 0.85, and we want this 0.5 is good. We want this particular dimension to be 0.015, and then finally we'll push it about 1 inch off of the edge. And then we can close and return back out, and you'll notice that it puts us automatically in a dynamic mode. But in this case we want to do through all and make sure you go in both directions. Now the reason we wanted to use the normal cutout is just to show you how actually it will respond when it goes through a bend. You notice here that the cutout remains normal to the faces that it was cut through. So that kind of gives you a nice example of how that works. We also have the capability of creating features and saving them off in a library. And in this case, what I'm going to do is I'm going to go to that library. In the working folder you'll find a PIM nut. And what I'm going to do is I'm simply going to drag that PIM nut into the view, and you'll see that it comes up with a feature set information dialog, basically guiding us through the process of placing this particular feature. So it tells me to select a face to place the PIM nut. Well, I'm going to select the face here. You're going to notice that it automatically attaches some geometry. In fact, these are dimensions. The first dimension it's looking for is the yellow dimension. So I'm going to identify the top edge and then the off the back edge. Remember, we made it an inch wide, so that puts it right in the middle. And then it says select the face for the tapped hole. So just by identifying the face, it'll put it in the center and very quickly create that feature for us. Now, when you're done, you can simply come up and hit the repeat button, but we already know how this form works, so I'm going to go ahead and close that and simply do it again. Again, we'll identify the top face, the right edge, and then place where we want the tapped hole, and you can see that it creates that feature for us very quickly. Another thing that we might want to do is get rid of sharp corners. Now corners can very easily cut somebody's hands, so when you're building models you want nice ways of doing that. I'm simply going to fence these two corners, these two tabs. You can see it gets each one of those particular corners. And then we're going to leave it at radius. In this case I'm going to set it to 5 or a ½ inch. And you can see that it consumes the whole tab. If you want to make a change, you simply select it, you key in the new value, and it creates those tabs for you very quickly. Now the next thing that we want to take a look at is in Pathfinder. When you start building features in a model, you might want to what we refer to as group them together, so that your list doesn't grow too long. So what I'm going to do is I'm going to go all the way back to the original flange that we created, and then we mirrored it. And I'm going to go all the way up to the break corner edges that we've created. And then what I'm going to do is right mouse button click and simply click on the group option. And you'll notice that it takes those particular features and puts them in a group. Now what I want to do is I'm going to go ahead and rename this particular group. And so we'll go ahead and call it left side flanges. Okay. And then what I'm going to do is I'm actually going to use the mirror option, mirror copy feature. We want to use the smart option, and then we will simply select that particular group. And then we're going to use the parallel plane option again. Select that front edge and make sure you get the middle of this tab. And basically what it's going to do is mirror all of those features to the opposite side very quickly. Now as we turn on our background components, you can kind of see how this is all